Alright guys, so I welcome every one of us to evaluating logarithm. Logarithm episode 1. This is going to be video episode 1 on logarithm, and we'll be viewing different examples and practical applications of logarithm. So let's quickly dive into example 1. So let's start from the basic. Log 1 base 4 is equals to 0. So not just log 1 base 4 only. So even if you have different bases, let's say you have log 1 base 5, log 1 base 6, log 1 base 7, log 1 base 8, log 1 base 9, log 1 base 10. All of these logarithm will still be equals to 0. So irrespective of the base, as long as the logarithm is 1, it is equals to 0. So quickly, let's move on to the next phase. Now the second phase, log 7 to the base of 7 is equals to 1. Now it is not just limited to 7. As long as the logarithm and its base has the same value, then the solution of such logarithm is equals to 1. So log 8 base 8 will be 1, log 10 base 10 will be 1, log y base y will be 1, log x base x will be 1, and log 100 base 100 will also be 1. So this is another thing you have to take, you have to have at the back of your mind in the concept of logarithm. So we have different ways of doing this, but since we are still in the basic logarithm part, we are still dealing with basic logarithm. Whenever you have a situation like this, you have to the base of 3, you have logarithm of 27 to the base of 3, you have to look for the best relationship between 3 and 27. And if you check vividly, you notice that when you multiply 3 times 3 times 3, you will get 27. So that is the relationship. So it simply means that you'll be taking two values out of the 3 that you have from the base of the logarithm, and you'll be left with just 1 3. Do you get it now? So the answer for this logarithm will be equals to 3. Or alternatively, when you write 27 as 3 raised to power 3 and you take 3 to the back of the logarithm, you are going to have 3 log 3 base 3, and log 3 base 3 is equals to 1, and 3 times 1 is equals to 3. So the answer for the logarithm is also 3. We have other method that you can use in simplifying this. As time goes on, we'll be reviewing that concept. Alright, we have another example. This is log 1000 to the base of 10, and this is as simple. 1000 can still be written as 10 raised to the power of 3, and since we have 10 raised to the power of 3 and 10 is also the base of the logarithm, then it simply means that our answer will just be 3. So that is that for that. So let's move on to the next example. So we have another example, log 0.0001 to the base of 10, and the answer for this logarithm is minus 4. How do we come about minus 4? This is a decimal value, and it has 3 decimal points, 4 decimal points, and which we can also be written as 10 raised to power minus 4. And from the concept that we've been using so far, since we have our logarithm to the base of 10 and we are having 10 raised to power minus 4, so this simply means that the answer for that logarithm is equals to minus 4. Do you get it? So if, for example, you have 0.01, that will be 10 raised to power minus 3, and the answer for the logarithm will be minus 3. If you have 0.1, that will be 10 raised to power minus 1, and the answer for that logarithm will be minus 1. So let's quickly play a mathematical game. Alright, so we have logarithm of 1000, and which we've already solved previously to be equals to 3. Now, whenever you see a logarithm that the base is not given, we assume that the base of such logarithm is equals to 10. So all of the logarithm present here, their respective bases is equals to 10. So now, since if log 1000 is equals to 3, this simply means that log 100 will be equals to 2, because that's 10 raised to power 2, that's 100. Log 10, that's 10 raised to power 1, that's 1. Log 1, which we've previously said that log 1 to any base is equals to 0. Now log 0.1, I explained that in our previous video. 0.1, that will be 0 raised to power minus 1, and which is minus 1. Log 0.01, which will be 10 raised to power minus 2, which is minus 2. Log 0.001, 10 raised to power minus 3. So you see, we came from 3 down to minus 3. So you should take note of these important rules when it comes to the concept of logarithm. Alright, so we want to do logarithm of fractions. So you see, when you have log 9 base 3, we've solved this earlier. Log 9 base 3, the answer for this is 2. 9 can still be written as 3 raised to power 2. You get it now? As long as 3 is also in the base, then the answer for this logarithm is 2. Now, how about logarithm of 1 over 9? Logarithm of 1 over 9, 9 itself can still be written as 3 raised to power 2. Now there's a slight difference between the first example and the second one. The first one is 9, the second one is 1 over 9. Now since the second one is 1 over 9, it simply means that you are ascribing a negative sign to it, because 1 over 9 can also be written as 3 raised to power minus 2. So, and the answer for that is minus 2. Now the second logarithm log 3 base of 9. Now in this case now, there is no way that you make the logarithm itself have the same value with the base. But what you are going to do is you are going to look for a way such that you simplify the base and it will have a number, if a familiar number with that of the logarithm. So in this case, what we are going to do, the base of the logarithm is 9. Now the 9, you write the 9 as 3 raised to power 2. Now there is a distinction. The first logarithm that we have is log 9 base 3. Now this time around we are having log 3 base 9. Do you get it now? So it is more like you are taking the inverse of the first one. So when you take the inverse of the first one, is just 1 over the answer of the inverse of the second one is 1 over the answer of the first one. Do you get it now? If log 9 base 3 is equals to 2, it simply means that log 3 base 9 will be 1 over 2. So we only took the inverse, we interchanged the inverse. Do you get it now? So similarly, we have log 1 over 3 base 9. Now log 1 over 3 base 9, you know that our previous answer is 1 over 2. And 1 over 2, how did we come about 1 over 2? Is because we have 3 there. So now we are now having 1 over 3 as a new logarithm. Then this implies that you are adding a negative sign to it. Do you get it now? Now, apart from that way, you can also do it this way. You can also simplify the base of the logarithm to be 3 over 2, such that you take that 2 to the back of the logarithm. But when you are taking the 2 to the back of the logarithm, instead of you writing 2, it will be 1 over 2. So it is a particular law of logarithm. So since the 2 is coming from the base and you are taking it to the back of the logarithm, this is indicative of the fact that it shouldn't be written as 2, but rather it should be written as 1 over 2. And you have 1 over 3 as a logarithm. You change the 1 over 3 to 3 raised to power minus 1, and you multiply it with the 1 over 2, you also arrive at minus 1 over 2. Now whenever you come about a logarithm question that is so confusing, for example, the first one is log 9 base 3, and you can solve that one, and the answer for that is 2, and you are not given log 3 base 9. Since you've gotten the answer for the first one, and you check the second one, that okay, this one is the inverse of the first one, then you just take the inverse and you have your answer. Now this is another pattern of logarithm. Now whenever you have 5 raised to power of logarithm of 14 to the base of 5 raised to power logarithm of 14 to the base of 5. Now as long as the base is the same as the number that is carrying the logarithm, then the answer is just going to be the logarithm. So that's 14. So if you have 8 power of log 8 log y base 8, the answer is y. 7 power of log 7 base x, the answer will be x. So take note of this. This is a special type of logarithm that we use. So let's move on to the last example for this particular episode of logarithm. This is going to be the last example for this episode, and as you can see, we have 7 power of log 7 of 7 power of log 38 base 7, and the answer is 38.